Hi, thank you for joining us today for our action-packed webinar on controlling applications in Cisco Wireless Networks. My name is Chris Legnano and I'm on the marketing team here at Action-Packed Networks. Before we jump into the presentation, I just wanted to let everyone know that if you have any questions throughout the presentation, feel free to submit them in the Q&A panel and one of our subject matter experts that we have here will be able to answer them for you immediately. We'll also be addressing some of the questions towards the end of the webinar, so be sure to stay on for that. With that said, I'd like to welcome our guest speaker for today, Damodar Banodkar from Cisco. Damodar is a technical marketing engineer with Cisco focused primarily on mobility. His main focus areas in mobility are BYOD, wireless security, and AVC. He's been with Cisco for 5.5 years, first as a software engineer and more recently with technical marketing. Thank you, Damodar, again for joining us today. I'll turn it over to you now for the presentation.
All right, thanks, guys. What we'll be talking about today is how do you provide tools that you can give to the IT to prepare network for providing applications and services in a scalable manner. So let's talk about the reality of applications today. So there is a major shift happening on the wireless side of things. The older networks were designed for more pervasive video or more pervasive applications and more for just coverage. They were not designed for real-time applications, and that's the major shift. So if you look at this classroom, almost everyone in the classroom is using multicast video. Now that's a real-time application, and what this real-time application does, it has a lot of impact on the user experience depending on the application response time. It can be very unpredictable, and what this also translates into is the traffic volume, which can skyrocket depending on the device type they're using. Now, we recently saw this when Apple released iOS 7. Everyone, all the devices on the network, started downloading the iOS upgrade, and that file was 1 gig. So if you multiply by the number of iPhones that you had on your network, that was the demand. So the traffic volumes can skyrocket and they are unpredictable. Also, in reality, the wireless experience kind of varies by the location that you are in. If you're in the classroom, which has just 5 students, versus a classroom where you have 25 students connected to a single access point, the user experience can be very different. And that's the reason you need to control the applications that are running on your network. Now, let's talk about what we're going to talk about today, right? We're going to talk about application control on Cisco Wireless. It all started when the iPhone was launched about 5 years back, and the consumers started getting their own personal devices on their network. And each of these personal devices, let it be the iPad or the iPhone, had a wireless interface on them. And it started with a phase called BYOD. But in the phase of BYOD, the IT was more concerned with how do you securely board this device on the network. It wasn't about providing a good service for them. But that thought process is changing now, because now it's all about providing a really good application experience and simplified operations on your network. And the applications can have different demands, right? Like if you're using Microsoft Lync or if you're using Cisco Jabber or WebEx, you want it to be a higher priority, regardless of the device type you used. So you can provide that using AVC on Cisco Wireless, and that's what we call the beyond BYOD phase, and that's what we're talking about today. So what's driving the number of devices on the mobile network? Well, first of all, most of the devices that you see out there do not have a wired port. So if you talk about the iPad, the iPhones, they don't have a wired port in them. In addition, even if you talk about the new iPad, the new MacBook Pros, they don't have a wired port either. So wireless is the only medium that these devices are going to use to get onto the network. In addition, when you're talking about high-density environments like a classroom, it's very difficult to put a wire for every client. And that's kind of driving all the users to wireless because it's an easier medium to connect to, and it's an easy and we need to provide high performance wireless for all the devices. Imagine a classroom of 100 clients or 100 students that are needing wireless. And you went to 100 students, that basically translates into something like 200 clients because every student will have their own laptop plus an iPhone or an Android device that needs internet connection. Also, application demands are increasing depending on the device type used, because it's no more that you use a different device for placing phone calls and a different device for streaming media. People are using the same device, the iPhone, for placing a call using wireless, for surfing the media, and streaming video as well. And when you're talking about real-time applications, they are intolerant to losses and delays, and the user experience plays a critical role. So that's why you need to manage those applications as well. And even though there are these like X number of devices on the wireless medium, the fact of the matter remains that even though the devices are changing, the infrastructure is changing, the physical medium is the same. Wireless is a shared half-duplex medium, and it has limited spectrum, and that's just the physics of it. So you need to design your network so that you utilize that spectrum efficiently. Now let's talk about the challenges that devices get onto your network. Let's start with asking a question. How much wireless bandwidth do we need for the mobile applications? Well, it depends on the application that you're trying to use. Every application has different bandwidth. Let's say if you're talking about audio, casual audio, it's going to be 100 kbps. A casual video is going to be 1 Mbps. Something like a file sharing depends on what it is. Like if it's BitTorrent, it can be 1 Mbps. It can even rise to 8 Mbps. Also, device backups such as Dropbox or Box.net, or even iTunes or iCloud, they can rise as high as 10 to 50 Mbps on your network. And you want to make sure that you control this application depending on the time of the day. If you have a classroom going on with 200 students in them, you don't want everyone to start using device backups. You want to control that application and put it in the background queue. So we'll be talking about that more. Also, what happens is the devices that you have today do not really mark application traffic inherently. So that's one more perplexing issue, because now if you're talking about an iPhone having a Cisco Jabber call, that device is not going to mark the traffic. So that's why you need AVC to prioritize the traffic and the first hop. That's the value add of having AVC on wireless. Also, application bandwidth differs by device type. So if you're talking about WebEx desktop share, on an iPad, that's going to take 250 kbps, but on a desktop, that's going to take 600 kbps. So you need to prioritize application based on the device type as well. So what can we achieve using AVC over Cisco Wireless? Well, you can categorize applications by device type and user group as well. So let's just talk about the simple example. You have different applications. You have WebEx and you have Cisco Jabber, and you want to mark them with higher priority. Let's say voice traffic. You would want to consider most of them as voice or video traffic. You can do that with AVC. What about non-real-time applications which are critical for your business, like Oracle or SQL or even Salesforce? You can mark them with a higher or normal priority depending on what you want to do. And about applications like Netflix or Pandora, they are casual applications that you want to mark them in a lower priority. As also, you want to drop malicious applications like BitTorrent that you do not want them to hog your bandwidth, so you can do that using AVC. In addition, what if there are 3 different users? You have the exec, you have the employee, and you have the contractor, and all of them are using WebEx, using different device type. What you can also do using AVC is make sure that when an exec is trying to get onto the network using his laptop, he gets higher priority as compared to employee trying to use WebEx using an iPad, or a contractor trying to use WebEx using Android. So you can have different priorities depending on the user group, depending on the application and depending on the device type being used. You can control all of these using Cisco AVC or wireless. So before we get into the details of AVC and how it's implemented on the wireless LAN controllers, let's talk about the wireless infrastructure. So the way wireless infrastructure is designed for Cisco is first you have the wireless LAN controller, and then you have the access points. So when your client connects to a Wi-Fi, it basically talks to the access point. But the access point sends all this data all the way back to the wireless LAN controllers, and that's when it goes out to the internet. And all the wireless LAN controllers are managed using a uniform, a single management platform called the Cisco Prime Infrastructure. So let's say you have two different clients trying to associate to the network and sending data. What would happen is it would connect, talk to the access point. The access point sends this data all the way back to the wireless LAN controller, which sits on the same campus in the data center, and then it goes out on the internet. The reason it was defined this way is because it makes the solution more scalable, because the access points have limited space, limited hardware resources, and limited code can be run on them to provide the full functionality. So let's do a deep dive into what's the exact communication that happens between the access point and the wireless LAN controllers. Well, the communication happens over a tunnel called a CAPWAP. CAPWAP is a protocol, and it's an encrypted tunnel that is formed between the access point and the control. Even though it's one encrypted tunnel, there are two applications or two different communication formats that happen inside this tunnel. The first one is the control plane. Now, that's the data that is communicated between the access points and the controller, and that's how the controller manages the access point by pushing configurations, getting the data out of it. It's more of a management platform that the controller uses. But the controller is not just a management plane, it also has a data plane. So let's say an access point of a client connects to an access point and wants to say access some data, it's a business application. The way it would do it is the access point would forward the client traffic to the controller using a data plane, and it goes all the way to the business applications. In addition to all of this, we also have a user-based QoS capability. So every session between the client on the wireless LAN controller, it can have a different policy, a different QoS policy. So in this scenario, on the right, you have two devices. One is an employee-owned device. The second one is a contractor-based device. And you can have different QoS policies for each device type. And the way this translates into is, let's say both of them are trying to access a call manager. Now, the call manager would tag the packets with, let's say, DHCP46. In this scenario, what would happen is, if you have a platinum QoS or a voice QoS for employee, that kind of marks the ceiling for the highest QoS level that is possible for that packet. So let's say an employee is trying to place a call using the call manager, and he has a platinum QoS. The call manager would mark the traffic with 46, and that would be the ceiling for that traffic. So all the employee traffic, which is coming from the call manager, would go in the voice queue. But for the contractor, the best effort, that's the ceiling. So even though the call manager marks the traffic with 46, the highest level that it can go to is best effort. So that's how you can have per user QoS policy. So it's all about driving on a freeway, right, and having different speed limits for different user types. So you can do that. Now with that, let's talk about AVC. Now, what does AVC provide? I would place AVC in three different buckets. You have the control, the visibility, and the planning piece of it. The control is really simple. You want to control the applications that are running on your network. If someone is running BitTorrent, you want to make sure that you drop the traffic or put it in a low priority queue so that it gets the minimum bandwidth. Also, from a visibility standpoint, you want to know what are the top 10 users on my network. Who's using the most bandwidth? And let's say for a given application like Netflix, I want to see what are the top 10 users for Netflix on the network. So that's what visibility gives. Now that talks about the V and C of AVC, but there's one more important factor which kind of talks about only the wireless aspect of it, and that's the planning. Because that's really crucial, because now as there are more devices on your network, you want to plan accordingly. You want to enhance the APs or add more access points to enhance the capacity. But before AVC, all you had was the throughput or the number of traffic, or the whole number. You just had, okay, there's 10 Mbps of traffic going through this access point. But with AVC, now I know what are the applications in that 10 Mbps. So if you want to add more access points in a conference room, you can just figure out, okay, what are the applications used in that conference room? If it's only Netflix, I don't want to add more access points to support Netflix. But if it's something like Jabber or WebEx that is being used in a conference room, I want to support that. I want to make sure that I add more access points so that every client in there can have a good enough experience using AVC. So how does the AVC work on the wireless LAN controllers? Well, the AVC works on the way it works is it uses the NBAR2 library to do deep packet inspection, and that deep packet inspection and classification happens on the wireless LAN controllers. We do not support AVC on access points today. So what happens is when the wireless client traffic goes from the access points to the controllers, that is where the classification happens. And depending on the policy that we apply, the application can go into real-time, interactive, non-real-time, or a background queue. And that talks about the classification and controlling the traffic using the policy engine. But in addition, what we can also do is we can use Netflow to export these records from the wireless LAN controller to either the Cisco Prime, which is a Cisco management platform, or we can actually export it to third-party Netflow vendors like ActionPact. So let's talk about application visibility. How do we identify applications using deep packet engine? Now, you can roughly put all the applications in 3 different buckets, starting with the easiest one, which is just based on URL and HTTP, like Netflix, YouTube. Even though they work on HTTPS, they are URL based. So you can take out the URL and figure out what application this one is. But in addition, there are non-HTTP based applications, right? Like Skype, BitTorrent, there is Viber, there's Gtalk. They don't always go to a certain URL or go to a certain IP address. They are kind of more difficult to recognize. And finally, there's the enterprise applications. Now, enterprise applications are the most difficult because, first of all, they don't always go to a certain IP address, and they are always encrypted. So they are the most difficult to recognize. Now, how does Cisco recognize all these applications? Let's start with Cisco Jabber. The way AVC recognizes Cisco Jabber is, even though when you place a Cisco Jabber call, is just one session, there are 3 different applications. And what Cisco does is it goes inside that one flow and kind of breaks down everything into Jabber video, Jabber audio, and Jabber control. And you can have different policies for each of these sessions. Now, it does something very similar with Microsoft Lync as well. Now, Microsoft Lync is, first of all, it uses encrypted SIP, or SIP TLS. So it's very difficult to figure out what the port numbers that the traffic is being sent on. That's why what AVC does is it runs heuristics on the data that is going through the wireless LAN controller, and can classify one single Microsoft Lync session into Microsoft Lync Media, Lync for desktop sharing, and file transfer. Also in media, it can classify differently based on Lync audio and Lync video, so it can do that as well. Now, how do you enable AVC on the Cisco Wireless LAN controller? Well, it's really simple. All you have to do is go on the KeyOS tab for the wireless LAN and enable it. Now, this is the GUI interface, the graphical interface for the wireless LAN controller and not the Prime. So all you have to do is just click a button and AVC is enabled on your wireless LAN controller. And what is the kind of visibility that you can see on the wireless LAN controller itself? Well, on the front page, which is the monitor page, under applications, you can see what are the top applications which are sorted by byte count. In addition, you can also get real-time stats for what are the applications that are running on your network in the last 90 seconds. So you can figure out which are the top 10 applications in the last 90 seconds. In addition to that, you can also figure out what are the DSCP markings per client in the last 90 seconds. Now, this is really useful. Let's say you get a call from one of your customers or one of your workers who's actually using Citrix, and he's not being able to access Citrix. What you can do is go and figure out what are the different applications that that customer is using, and then you can mark the priority. So let's say he wants to use Citrix, but he's using Netflix as well. What you can do is drop Netflix and mark Citrix with the highest priority so that the applications kind of go out in the right order. We also, in addition to the real-time stat, we also have the historical data, which kind of gives you the cumulative of the total bytes transferred and total bandwidth that is being hogged by a certain device. You can do this on a per SSID basis, or you can do it on a per client basis as well. And it also gives you the applications by percentage of total bytes. Now, before we go further, let's talk about application control. Now, you can control the application usage and performance by actually classifying or marking the traffic with a certain priority. Let's say you have Lync and WebEx. You want to mark it with a voice priority, which is the platinum, which is what we call on the Cisco Wireless LAN controllers. We have 4 different metals that we classify the QoS properties by. There's platinum, gold, silver, and bronze. Bronze is background, silver is best effort, gold is for video, and platinum is for voice. So you want to make sure that you classify Lync and Cisco WebEx as voice. Now, if someone's trying to use Citrix or let's say Office 365, you want to classify that with medium. You can either do silver or you can do it gold, depending on what you're comfortable with. Also, if it's Pandora or FaceTime or Facebook, depending on if it's critical to your business or not, you can actually put it in the bronze queue, or you can give it a custom DSCP marking so it can be taken care of at the switch itself. In addition, you can also drop most of the traffic that you don't want, like Netflix, Skype, or BitTorrent. If you don't want it in your enterprise, you can actually drop it, or the wireless LAN controller itself. So how do you apply this AVC profile? It's really simple. So all you have to do is go on the wireless LAN controller, go to the AVC profile, edit the create a profile called corporate applications. And in this scenario, we have created a profile which says drop BitTorrent, drop Facebook, mark Citrix with prior DSCP 34, mark Lync and WebEx with 46, and put Pandora with 10, which is like the background queue. And you can have 32 rules per AVC. And all you have to do is go and associate this profile with your wireless LAN, and that's it. And it's all going to be taken care of at the wireless LAN controller itself. In addition, we realize that applications change on a daily basis, and that's the reason what we have something called as a protocol pack. Now, protocol pack, there are major and minor protocol pack updates that you can install on the wireless LAN controller itself. So when you install a protocol pack, what would happen is it would install new protocols. At the same time, it would update and fix, let's say for Skype. Now, Skype keeps changing the protocol with every release. What you can do with this is you can install the protocol pack such that if something has changed with Skype in the last 2 months, with the protocol pack, you can now twist the way Cisco recognizes Skype and make sure that we recognize it correctly. And you can download the protocol pack as long as you have the contract with Cisco. You can download it from the CCO website, and it's published every 2 months. And one of the good thing is when you install a protocol pack, you do not need to reboot the wireless LAN controller. So it's on the fly that you can just go ahead and change it without disrupting anything on your network. And finally, let's talk about Netflow. Cisco uses Netflow V9. So basically, it uses Netflow to export the records, and V9 is the format that it uses. So some of the fields that it exports are the client MAC address, the client IP address, the SSID that the client was associated to, the access point MAC, along with the packet data, the application tag, so you recognize what application is being sent, and the DSCP markings before and after applying AVC. Now, one of the partners that we've kind of tied in with is LiveAction. And one of the great things about LiveAction is using their dashboard, we can actually figure out the application visibility from end to end, from wired, wireless, all the way to the internet. So in this scenario, in the snapshot that you have on your right, you have an iPad that is being associated to an SSID. You can figure out the applications that are flowing all throughout the network from the access point all the way to the internet, going to the switches, going to the routers. You can see the end-to-end flow, and it's really great when you're trying to troubleshoot something. Also, if you're trying to get a more granular visibility into what are the applications running, you can take a look at the applications per switch. You can do it applications per access point. Now, this is really great because let's say if you have an access point in the conference room and you want to know what are the applications running in the conference room, you can get that data using LiveAction and figure out, okay, these are the applications that are running in the conference room, so that's fine. If they are going beyond the demand, you can add an access point in there. So this is really great even from a planning standpoint. And you can also have the applications running per SSID. In addition, what we also have with LiveAction, we have a tie-in with the username. So let's say you want to figure out what are the applications being used by a certain given user. So you get the username using the AAA Radius authentication, and you figure out what are the applications being used by that user. In addition, you can also get a DSCP marking for all the applications being used. So the way you kind of export this record is you go to the Netflow in wireless. It's in the tab under wireless. Go to Netflow, create a monitor, create an exporter, and make sure you associate an exporter with a wireless LAN, and that's how the controller is going to start sending the wireless data out. So if you want to know more information about AVC and verification and how it helps you improve the network performance, we did a study with Syracuse University, and that's the link for the paper. With using AVC, they improved the MOS score for Microsoft Lync Voice from 3.9 to the perfect score of 4.2. Also, they improved the Citrix video streaming quality by 55%. Now, this was in the presence of a background traffic of file sharing, which dropped by 74%, just because we prioritize these two applications, making sure that the right applications get the right priority. So now that we covered AVC, so we're talking about application experience. But for the BYOD devices, we also need to talk about the services that we provide in addition to having improving the performance of the applications. So let's talk about the Bonjour Protocol. Now, Bonjour Protocol is being used in a lot of enterprises and schools, and it's really great for most of the iPhones to talk to the Air printers and the Apple TVs. Now, Apple TVs are really great for AirPlay mirroring and making sure that you project your screen in a classroom or your screen in a conference room. But there's an issue with this. The protocol that is being used by the iOS devices or by even the Macs to find the services is called Bonjour. Now, the Bonjour is link local, so it does not cross subnet. So the issue is, let's say you have all your services on VLAN 20 and all your clients on VLAN 10. That Bonjour request will not cross subnet and you won't be able to discover the services. That's where the Bonjour challenge comes in. What happens is, in this scenario, you have your Apple TV and your iPad on the left on VLAN X, and they can discover each other perfectly fine. But if your iPad wants to discover the Apple TV on the right, which is on VLAN Y, the router is going to drop that link local multicast and it can't be routed. Now that's where there's an MDNS gateway on the Cisco Wireless LAN controller which would help you. In this example, let's say you have an AirPrinter on VLAN 23, Apple TV on VLAN 20, and an iPad on VLAN 99. Now all these three devices are different VLANs. So without the Bonjour gateway, they would never discover each other. So what the wireless LAN controller does is it kind of goes in a listening mode where it listens to the Bonjour advertisements from the AirPrinter and the Apple TV, and it maintains a cache. So now the wireless LAN controller knows that the Airplay is on VLAN 20 and the AirPrint is on VLAN 23. So when the iPad asks for an Airplay, it sends a unicast request going from the iPad to the wireless LAN controller, and the controller responds back with a unicast saying Airplay is offered on VLAN 20 and that's the IP address. That's how you can actually start using the Apple TV on a different VLAN for projecting or mirroring your display. So that's the way Cisco WLC resolves the MDNS issues when the services and the clients are in different subnets. In addition, as I mentioned, the wireless LAN controller sends back a unicast response to the iPad. Now this is really important because with this, what happens is the Bonjour service is not being broadcasted to almost every access point in your subnet. It just goes to the controller and gets a response back, which results in amazing Bonjour traffic optimization. Now we did a customer survey some time back, and we realized that the customer was using 500,000 packets, 500,000 packets per hour was just Bonjour. And the issue with Bonjour is it's sent at the lowest data rate. So it actually brings the performance of the entire network down. By enabling Bonjour Gateway, you get 80% less Bonjour traffic and 100% less Bonjour multicast traffic on your network. And this is just with 4 access points. So as you improve the access point, you can get almost 90 or 95% less Bonjour traffic on your network just by enabling this feature. In addition, we can also classify or filter the services by user group. Let's say you have a network and you have a single SSID on which the employees and the contractors associate. Now what you want to do is you want to make sure that the contractors can just use AirPrint, but the employees can use Airplay, AirPrint, and file share. You can do that using Bonjour Gateway. Also, some of the common Bonjour services that we can see is Airplay and AirPrint. Now, even if you're talking about Airplay, it uses multiple services inherently inside it. So Airplay uses Airplay, Apple v2, which is used for Mac OS X, and it uses for audio, it uses ROAP. So those are the 3 most common services used inside the Airplay service itself. Similarly, on the AirPrint, you have Internet Printing Protocol, you have the printer spool, you have HTTP scanner, and the printer PDL data stream. So there are different services depending on which are inside the AirPrint service itself. So in addition to most of the things that we discussed, we also do location-specific services. So let's say you have an Apple TV and you want to make sure that you kind of restrict the Apple TV to a given area. You can do that by using a location-specific service on the Cisco Wireless LAN controller. Also, what we also discovered is most of the times your Apple TVs are kind of wired and might not be on the wireless network. And one of the requirements that we had before was the remote VLAN on which the Apple TV was connected on, or the wired Apple TV was connected on, has to span all the way to the WLC. But we realized that cannot be the case because sometimes what happens is the wireless LAN controller is on a different subnet which is sitting on a data center, and the VLAN on which the wired Apple TV was connected on is restricted to a given building only. So you can use something called an MDNS AP, which helps you discover these remote Apple TVs which might be on your network. So what we talked about today is we talked about two big features that we have on the wireless LAN controller. We talked about AVC, we talked about Bonjour, and both of these are enabled on a wireless LAN controllers. A wireless LAN controllers has a huge portfolio depending on your needs, depending on your scale, and then features and performance. It starts with the low-end one, which is 2500, which handles about 50 APs and 500 clients. We also have the SRE module, which sits on your routers. On top of that, we have the two biggest platforms that we have. It's called the Vism 2 and the 5500. 5508, it's the wireless LAN controller, which can handle up to 500 APs and 7,000 clients. And you have the Vism 2, which plugs into the Cat 6K, and it can handle about 1,000 APs and 15,000 clients. In addition, we also have the 8500, which can handle up to 6,000 APs and 64,000 wireless clients. That's more of a service provider, but we see it being used in enterprises as well. In addition, we also, if you do not want to have a physical platform, we have a virtual controller that you can use, which can handle up to 200 APs and 3,000 clients. And then you have the Flex 7500, which can handle 6,000 APs and 64,000 clients. In addition to our legacy platforms, which were running on the Air OS, which is not the iOS, we also have launched a new platform. It's called the Converged Access. What it does is it converges wired and wireless on a single platform. So before we had a different switch for wired, a different switch for wireless, and then we had all these multitude of platforms for identity services and management. We've kind of taken all of that and integrated them into one platform. So we have the one policy using the identity services engine, and we have one management using Cisco Prime. And all of them can be handled using these two iOS-based switches that we have. We have the 5760 and the 3850. Both of them use the same ASIC or the same hardware and have the same interface. The 5760 is more of a wireless LAN controller, and the 3850 is a switch which can terminate the CAPSAP tunnel. So basically, it can terminate the Cisco access point on the switch itself and doesn't need a separate wireless LAN controller. The 5760 is more of a platform where you want to have a more wider deployment with, and if you're comfortable with the old Cisco model, you can have the 5760. But if you have a branch where you just don't want a separate box for managing the access points, you can have a 3850 as well. In addition, we also have the downloadable ACL support. So that way you just configure all the policies on just one box, which is the ICE, and push these policies to all the switches and the controllers that you have. So it kind of gives you that flexibility and simplifies your deployment for BYOD. You can we also did a Myrcom verification for the 5760 and 3850, so you can go to that link and get the latest report. In addition, what are the network requirements? On almost all the platforms we support AVC. The only difference is on the unified access and on the unified access of 5760 and 3850, the iOS-based platforms, we do not do control today. We just do application visibility, and we do Bonjour gateway on it. It's just after 3.3. And on the iOS-based platforms, we don't have the protocol pack update as of today. As far as LiveAction goes, you can actually support AVC monitoring using LiveAction 3.0. So just to summarize what we spoke about today, we saw how the thought process in the entire industry is changing. It's not about just securely boarding the device. It's also about how do you provide application experience and simplified Bonjour operations to the clients running on your network. If you want to see more, if you want to see both these demos in action, go to the URL over there, so you can see Cisco AVC demo as well as a Bonjour services directory demo on these links provided on YouTube. If you want to get more information about Cisco, follow us on Facebook, Twitter, go to cisco.com/co/wireless. for Action Pact, follow them on Twitter. They have a Facebook page. Download a free trial of LiveAction and see how it performs. So with that, I'm done with my session, and I'll be happy to answer any questions that might be there.
Great. Thanks, Damodar. That was really informative and a really great presentation. I do have a couple questions in here that maybe you could answer for us. So the first one is, why would I need AVC on wireless if I'm already performing AVC on the router?
Well, that's a good question. What happens is if you look at most of the deployments that you might have today, what happens is, let's say if you're talking about Cisco Jabber, that traffic does not always get routed on the internet. And it's most of the peer-to-peer traffic that might be necessary for your enterprise that doesn't get to the router but needs to be optimized. So by just having AVC on your router, you cannot optimize that traffic, and you need AVC on wireless for that. Well, certainly you can, if you're talking about optimizing traffic that goes on the internet, you can do that on the router as well. But AVC on wireless kind of gives you that optimization at the first hop itself, before the application converges or goes throughout the entire network.
Okay, great, thank you. And then I have another one. Does the G-packet inspection have any impact on client performance?
Well, we've done some primary tests, and so far it can have like a 10% impact, but not anything worse than that. So far we've had deployments where they turn on AVC, and from an application, from a user experience, it doesn't really have any impact.
Okay, great. And I think most of the other questions were answered by the subject matter experts offline. So thank you so much again, Damodar, for joining us today, and thanks for everyone who attended. I hope you found it informative. The recorded presentation and a copy of the presentation will be emailed to you, and it will be available on our website shortly following this. And again, if you haven't downloaded a free trial of LiveAction, there'll be a link to it after the webinar is over. So with that, thank you and have a good day.
All right, thanks, guys.
Thanks, Damodar.